Hello guys and welcome back to this episode of this tutorial series. In this episode we're gonna make sure that we understand the PCB editor, which is probably the most important tool in your arsenal. First, we have created this real nice schematic, as you remember in the last episode, very basic example, but now we need to convert that into a board. Now in episode 2 I showed you the entire process from start to finish, but this way we're gonna explain the PCB editor. Now when you open the PCB editor like this, I'm gonna open my project. It's already done. It's opening like this. Okay, so first, before we start working on the design or explaining everything, we're gonna go about it like really quickly to get familiar with the interface. First of all, this interface here toggles stuff on and off and makes some choices. We're gonna explain all of them briefly. This is where you're gonna make sure all your time is poured into. These are the tools that you are going to use during your layout, like drawing tracks, drawing pores, drawing edge connectors, and maybe something like a silk screen. Basically, all of these. So this is the most important tab or column that you're gonna find. It is already divided into something like the Corsair, and here are the PCB design stuff. Here are the drawing tools, the tables, and the deleting tool, etc. We'll go about all of these in order. This is called the appearance tab. Now this appearance tab makes you look at every single layer or division on your PCB, like the front copper, the back copper, the silk screen, maybe user layers if you want to add some notes to your manufacturer, something like this. Okay, so let's go about this later. Here it's called the selection filter. Now when you select like this, for example, or like this, what can you actually select? By default it selects everything except for something called locked items, because maybe you want to lock this thing up and you don't want it to be selected, and when you are done you want it to be reselected again for unlocking. You're gonna do that from here. So this is these two are explained. Now here is the typical any Windows program has these: the saving, the plotting, these three plots stuff or prints stuff, undo, redo, find, refresh, etc. The zooming in and out, and zooming to the board, mirroring, X, Y, and rotating. But all of those will be used by the hotkeys. Nobody actually uses these buttons. Grouping, locking, and unlocking, as we explained before, which are gonna be used also by hotkeys. Here is the footprint editor, which is this thing right here. If you want to edit a footprint that you are using, you can basically refer to that. We're gonna explain this in a separate video, by the way, because this is not something that's so simple. The library, all of your footprint libraries, as you can see, and you can basically select, for example, inductor, surface mount, and you're gonna like browse your library, check it out, and if you like one of those you can basically insert footprint into board, but it will not be associated with any schematic symbol. This is not really a good thing to do, but maybe you want to do that for some reason, like mounting holes or something. But even those, it can be linked to the schematic, because once you start updating, sometimes KiCAD will remove the unassociated footprints. Moving on, the 3D viewer, basically the 3D viewer, and you can say Alt and 3, which is the hotkey for that. Next important button to update everything from schematic. Maybe if you have modified something in here and you saved, now you wanna move to PCB and check this, you will find it here and you can press update and it will update it here in the PCB. Some options, for example, right, like delete footprints with no symbols that I talked about before we started talking about this, which is this library symbol was all about. Maybe you added a footprint for a capacitor, but that thing doesn't exist in the schematic. Now, if you have this on, when you click update, it will be removed. But if for some reason you don't want that, you can basically not select this. Delete and replace footprints even if they are locked. Self-explanatory, and everything here is self-explanatory, but basically this, when you click update, it scans the schematic and scans the PCB. Any difference between the two of them gets updated in here. Design rules check, similar to the schematic one, checks everything and reports back errors and warnings. And this one gets us back to the schematic, and this one is for scripting, which is not really something that I can do. Okay, so basically everything else here is the similar tools, but organized in these tabs. Now, once we have familiarized ourselves with the interface, I forgot to mention here you can say some statistics, how many pads, how many vias, the current dimension, the current point in the grid. Maybe this is x equals 144, 164 is for positioning stuff, and basically the grid that you are using, and so on. Here you can select several minor options that can be, for example, useful. First of all, the predefined tracks. We will go about this when we start routing, but basically if you have predefined track widths that you like, you can find them in here. Net classes size is similar for vias, tracks and vias, predefined. Currently active layer, you basically select it either from here or from here. And the grid. Here are the default grid sizes that you can use. Maybe 5 mils, 1 mil, etc. And maybe you can edit grids and you can add your own in here and select it. For me, I always go for the extra fine grid because I like to move things in precise. Zooming, basically the mouse wheel gets you all the zoomings that you need. Now, let's start by removing everything and saving. Let's start from the beginning. Now, once you have finished your schematic and you're proud of it, for some reason you should be, and now you want to make it into a board. Before anything is done, similar to the schematic, we're gonna go to something called the board setup. Previously it was the schematic setup, now it's the board setup. Go to the first option, which is the board SketchUp, and we go to the physical stackup. I'm sorry, stackup, not SketchUp. The physical stackup, most important setting of all time. How many layers is your PCB? Is 2 layers or 4 layers? Basically, you're gonna be either 2 layers or 4 layers for beginners and even some advanced people, unless you really need bigger layers. Basically, you can choose that from here. And here are the layers that you will be concerned with: front silk screen, front paste, front solder mask, front copper, then the dialect, which is the core, and then basically the same but for the bottom layer. Now, all of these are not the scope of this tutorial because this is general PCB knowledge, but basically it's very simple. It is how your board is gonna be sandwiched and made. Basically it's FR4. For example, the copper layer are 0.035 millimeter, etc. The color, whatever. But these, I don't really recommend you play with these unless you really want a certain stack up and the widths and stuff like that are not standard. Basically, you can put them in here. Very simple. But for almost all people, you're gonna leave these the way they are. But you can basically choose 4 layers, for example. So now I have front and back copper as well as inner 2 and inner 1. And between each layer, there is a dialect layer, 1, 2, 3. See? This is a pre-preg, this is a core. Basically, how PCB is made. The center is core, and the other pre-pregs, and here are everything. So for me, I want 2-layer board. Okay. Okay, let's start by doing that. 2-layer board. Now we go to the layer editor. Here are all the layers that we have in our board. Notice that now it adds other stuff like user layers and eco whatever, and courtyards. All of these basically are the layers. You can basically assign something to the front or back copper, signal or power plane or mixed. Really not so important because it's just a name. Eventually you're gonna do whatever you wanna do. After we decided the stack up and looked at this, go to the board finish. Now these can be options hardwired into your design, which will make them by default going to any PCB manufacturer. Like if you want castellated pads or plated board edge, or maybe what is the copper finish that you want, maybe hard gold, maybe immersion tin, maybe none, maybe whatever, you can basically select it here, and it will be displayed with your Gerber files immediately when you upload it to the website. I don't really recommend this route, because first you have to design your board, then make your choice when you upload the board to the manufacturer. Do not do that in here. This is for solder mask and solder paste. Basically the settings which should be as accomplished as accompanying your PCB manufacturer themselves. They should give you the tolerances, and you should put them in here, but basically keep them as default for now. Text and the graphics, line thickness, text width, formatting, text variables, basically the same thing as before. Your preferences. Now, design rules. This is the second most important settings in PCB layout. After we have decided the physical stack up, and after we decided everything and our mind is very ready for it, now we're gonna go to the PCB manufacturer website and check their capabilities. And according to those capabilities, we're gonna fill them in here. For example, the minimum clearance, maybe it is like 0.1 millimeter for a certain manufacturer. Maybe another one that you're gonna use, which is very cheap, maybe it requires 0.2. You're gonna put them in here so that when you route and work, KiCAD automatically gets these constraints and applies them. Maybe if you get closer to a certain track, it will stop right there. Why is this important? Because it's not really funny when you finish the design and you route everything, only then to know that, well, your manufacturer can't do these tolerances. Please redesign that all of it again. It's really not fun thing to do. So basically, make sure you go to your manufacturer capabilities page, understand them very very clearly, and basically just put them in here. And all of these are self-explanatory, like this annular ring, for example. What is the minimum? What is the minimum diameter that they are capable of, etc. Copper to hole clearance. No one needs to explain this to you. It's like self-explanatory. It's English, and so on. Micro vias, if you are that, silk screen, basically that. Once you are sure you are fine with all of these, like I do, you can basically press OK. Predefined sizes. We have basically talked about the tracks and vias of predefined sizes that you are gonna use like a lot of time. Maybe I can add like 0.5 millimeter track and 0.9 and diameter via with 0.6 hole. Differential pairs are the same as the tracks, okay, the same thing. And I hit OK. Now, instead of doing like the regular size, which is 0.2, I can basically choose a predefined size, which is 0.5. And when putting via like this, for example, I'm putting a via, instead of that, I'm gonna choose something like this. Now the via has changed to my predefined size. I don't really modify these sizes myself, but it is really worth mentioning, and it can save you a lot of time basically. Okay, so let's get back to track. And let's, for example, I'm gonna delete all of them. I don't require that for now. Teardrops. Now look at this track. It's connected to this via. Now you can basically add something like this, like a teardrop. It will make the via and the track more solderable. It's basically a better overall. Now the length, the diameter, the width of the teardrop, basically you can select it here for all types of pads, through hole and round shapes and rectangular and tracks, as well as like every other option. Basically I'm fine with the default such as many people, but you can basically, if you want this length to be longer, you can basically put them in here and press OK. Length tuning parameters. Now advanced boards really has many signals. Of those signals are time critical signals that needs to be the same length as each other. For example, if you have a RAM chip, RAM or DRAM or whatever, it has address pins and data pins. For example, let's call them 8 data pins, or maybe an HDMI signal which has the data pins of the HDMI signal, whatever. Basically, you have many signals that must be time critical, meaning the time that they are getting out from the generating IC to the target IC, that they should be generated, and they are generated at the same time. But you as a designer, you need to make sure they arrive at destination at the same time. This is really advanced, and it's getting required more and more these days. How can you make sure of that? Well, you're gonna do something called length tuning for single tracks and for differential pairs. We're gonna look at differential pairs, and if something of a mismatch between the differential pairs, like one of them slightly shorter than the other, you can basically self-adjust that in here. Now, what is the radius that you are okay with? What is this distance between I think they call them neanders or something like that. If you want to laugh about it, I call this macaroni or something like, or pasta, because it looks like that. The amplitude, whatever that you are comfortable with, and these things really affect not just the timing but also the crosstalk between the two signals. Basically very important and critical. You can just assign the default values in here, and I'm gonna show you how can you manually adjust these as you should. Net classes. You remember the net classes from the schematic symbol. Now they are all gotten into here because we only have the default, which is the 0.2 and the 0.2 track width, like we just saw right now. When I go to the net class, the default is 0.2. Now when I go back here and I see a net class that is called power, which I got from the schematic, now I can redefine something like 1 millimeter for track width. Now I have the net class name and all the parameters that I want to modify of the default thing. Now, who are these signals? Basically 3.3 volt, which is gotten from the schematic. I can literally add something else, like for example G and D, for example ground, and I put ground for power. I can here add another net class, multiple net classes and multiple assignments. I'm done. It's okay. So we will test that later on. Custom rules, if you have I really don't know about this, I never used it. And violation severity. This is also important because when you click on the design rule check, it's gonna make you a list of or more of a report. Now it goes into all of these tests and all of these types of errors and basically present them to you. For example, let's go to the schematic parity, and we have something we call missing footprints. Now if there's a schematic but it doesn't have a footprint gotten into the PCB designer, I wanted to make it warning, because maybe nothing is wrong, it's just something is missing. But for me, no, I want it to be an error, because when I make a design rule check like this, see, there are many errors, and all of these stuff in here, for example, I want this to be an error, and maybe duplicated footprints. If something has two footprints for it, I want to make it an error, because a warning is maybe something minor, something that doesn't really affect the PCB itself. For example, if you have a silk screen that is on top of another silk screen, that's not gonna make any difference, but it's just more for aesthetic. But for anything severe, you're gonna make sure it is error, and press OK to accept that. Embedded files, here is a feature that is added recently. It allows you to embed files in the file itself. For example, if I have a library or maybe a footprint of some sort, I want it to be embedded with this file, so that when I give it to other people, it will automatically load it without them needing to put this stuff into their PC and into their generic library. Once we are finished with everything, we're gonna press OK and save. So now we have decided that everything about our board, we have set it up, and we are ready to move on. First option, always you have to choose it, is this thing. Please give me everything from the schematic that doesn't exist here, which is basically everything. And we're gonna make update, close. Now as you can see, it has all the footprints of my schematic symbols attached. Okay, so if you want to choose something, click and drag from left to right. It's gonna select everything that it's included in the box. For example, I have C2 in the box, but C4 is not fully enclosed. It's gonna select C2. But if I go from right to left, anything it touches, it selects. For example, like this. And one of the most important hotkeys are the M. When you highlight this and press M, it moves. Another hotkey is E. E means edit. Let's go to the properties of this thing, and maybe we can edit it in here. You're gonna have something like R to rotate, X and Y. No, X for routing. I'm gonna select this pad or hover over it, and I'm gonna say X. It's gonna route, and notice that once the track is out, I'm gonna press E again, and I can basically make it 0.2, make it 1, make it whatever. But since it is a 5 volts, since it is 3.3 volts, it's gonna be 1 by default. This is the ground, and basically I can route anything. And one of the important things is, if you want to mirror something like this, you can use this here, but rotating is always used from this. Now let's start by moving this USB C right here, a USB B connector right here. After we have added everything, now let's go check these layers. The front copper, the back copper, basically nothing exists until now. But the second step after importing everything is to actually determine the shape of the board. Right now, if you go to the 3D, it tells you there is an error. What is the error? The error is that we have not defined the shape of the PCB. It's just estimating it. So let's go to the edge cut layer and let's start, for example, drawing a shape, maybe like this. Okay, now Alt and 3, and now the shape is there. And maybe you can do stuff like select this, let's move it, rotate this, put it right here, and now let's start by doing that. This one adds a footprint similar to the library thing. Select for any footprint that you want and basically okay, and you're gonna add it, but it's not gonna be associated with a schematic symbol, and I don't recommend this. Everything must be linked with the schematic. This is the routing tool. Basically I'm gonna either press X for this pad and start routing, or basically press here and select the pad that you want and basically start routing. But before you start routing, make sure you get out of the edge cuts to one of the copper layer. See? Now this track is probably 0.2. Let's go to the properties, track width. I'm gonna make it 1. Okay. Here is 1 by default because it's the net class that we have assigned. The 3.3 is also 1. Ground is also 1. Okay. Now the other tool, if you keep pressing here, you're gonna see something called differential pairs. Let's explain it right now. So this is a USB connector. The USB plus and minus are what's called a differential pairs. Differential pairs are basically two signals that are routed together and referenced to each other. KiCAD has a certain way of using differential pairs. For example, I can just do a differential pair, for example, like this. See, it doesn't accept. The only thing that I know of that is practical is to go here and remove, let's remove these. Okay, previously we didn't want to connect anything, but for the sake of this tutorial we will. We're gonna press a label, we're gonna call it anything that you want, maybe USB. We put underscore and P, which is for positive, and the same name but N for negative. Now KiCAD now has the notion P and N to make sure this is a differential pair. We're gonna tell them, hey man, these two are differential pairs, not single tracks. Save. Let's get back to the PCB design and press import changes. It tells us that we have changed these. Update, and now they have this. I can basically route them by pressing X, similar to any other routing method, but here we're gonna see that we don't want to use X, which is single track. We want to use differential pairs. Where can you access differential pairs? From route menu, either single tracks or differential pair, or maybe press 6. When you memorize all of these, it's gonna be easier. Now I'm in differential pairs. Look what happens. I assign myself here and press. It highlights both of them, and look at this. These are routed together as they should. Now the next tool, it's called tune the length of the tracks. For example, let's first let's track this, and let's assume that this is correct, and let's assume that this is correct. Now certain signals require certain lengths to be matched. For example, this track of mine, maybe I'm not really happy how it is going. Basically I can drag it right here. For example, this is my track, and I'm not really happy about it. I'm gonna go to here, keep pressing. Here is tune length of a single track, which is like this one, tune length of a differential pair, and the skew, which is for differential pair. I'm gonna tune the length of this one. When I hover over it, it tells me it is 31.9. When gonna press, I pressed, now it is highlighted. When it is pressed, I'm gonna say E. E gets me to manually override the length tuning. Now for this track, I want it to be 50 millimeters. And for the spacing and the amplitude, I'm really happy about them. I'm gonna press OK. So now, see, when I move the mouse here and there, it's gonna start adjusting until it is roughly 50 millimeters. Okay, I'm gonna press left mouse again and it's done. Escape to get out to the pointer, and I can basically select the track. Now KiCAD knows that I am really having this as an extra to the track. I can basically move it and adjust it the way I want. Notice that the interactive routing. Now I'm gonna make it a little bit bigger, and this, look, it is right now, the current length is now precisely 50 millimeters. Maybe if I choose to do this, it starts to dip back. So these are called the interactive routing. I'm gonna do the same but for the differential pairs. Differential pairs, press left mouse once, then E for edit. This is about 29. I want it to be 50 again, and I'm happy with everything else. Okay, now I move the mouse without pressing, and notice how it makes the spaghetti. I call it spaghetti, that's what I call it, and I'm happy about it. Now it is 50 millimeters. Press OK. Now we're gonna see if we can adjust the skew. You see, now when you put in here, it tells you the length of each one. Maybe if you don't like this, you can basically see it tells us that this one is 1.3 millimeters short, and this one is 1.3 millimeters longer than this one. So either I adjust this, I can't adjust this because it is already longer than this one, but I can adjust this by using the skew tool. Press at this one and basically move until it is now 0. Press OK, and that's about it. This one now is 0 and this one is 0. Basically the exact same length between the tracks themselves, the differential pairs themselves, away from the entire differential pair signaling. So these are really worth mentioning, and they are really important for high-speed signals and if you want something professional. This is placing a via, basically place a via, and now the via is still not placed. I can press edit, or maybe the right mouse button, select via from the sizes. If I really have a predefined size in here, I can press that. The other way of having a via is when you are routing right here, you can press V. See, when you press V, now a via is inserted. Now before I press left mouse again, I can press here left mouse again, and now I am in layer 2. I'm gonna route, I'm gonna get out from here from another via, but I'm not gonna press the left mouse button. Click edit. Now you can check the via diameter. Basically keep the diameter of the track the same, but the via diameter I want it to be 1 millimeter and the hole to be 0.5 millimeter. Okay, and now as you notice it got a little bit bigger, and continue until you reach here and press. Now this is a fully routed trace. Let's go to the 3D, and here it is. So these are the vias and the tracks. Now basically you can track and put vias as much as you want. You have everything in your arsenal. Now let's go to the next tool, which is the filled zones. Okay, now this 3.3 volt, as you can see, a voltage regulator. It is really big, and I want, instead of tracks, I want to make a polygon pour. So I choose this, I define the starting point, press left mouse button. What is the thing that you want? I want 3.3. I want it only to be on the top layer because this is in a surface mount. Sometimes you want it to be on both layers. Okay, now let's go to the zone name. Name it 3.3 volt pour, for example. The level, basically, the more levels when two collides with each other, with two polygon pores collide with each other, which one should be the priority and which one shouldn't be the priority? It's defined by the priority level. The shape is locked or not locked, hatch or not hatch, not really important because we're gonna fill it immediately. Corner smoothing. Maybe you are, we will check that again. The clearance is basically derived from your design rules, and now we have to choose between thermal reliefs, solid, and other options. And the fill is solid fill. We don't want hatched patterns. Maybe you use this with rigid flex PCBs, but basically for everything else, solid. And remove islands is when you have a pour with everything is covered except very tiny areas that have small islands remaining due to the constraints and many options. We can basically just remove those because they are useless. Okay, I'm okay with it. Now I have to draw it. Let's draw it right here. This is 3.3. I'm gonna roughly like put it like this, and you're gonna do that, zoom until you click, and now it is determined. Another shortcut, which is pressing B to refill. Now it is refilled. Notice these are called the thermal reliefs. Notice here, these are not really connected despite being in the copper pour itself. Let's try pouring again. It's not, because we are using a big clearance. We can select the copper pour and we can basically try to adjust it. I don't want the clearance to be half a millimeter. Maybe 3 is enough. And okay, press B again, and now we have gained another option in here. Let's get back here. Instead of selecting thermal reliefs, let's start by doing solid and press. Now it is a completely solid copper pour in here. Now copper, which is solid, is more effective thermally, is better in electrical connection, but it has a problem when it comes to soldering these ICs, because when you start soldering, because it is so big and so flat, it's gonna suck too much heat and maybe can cause you problem. That's why they use a thermal reliefs. But in my personal experience, I always go solid on such applications, except maybe, for example, let's move this. Let's move this in here, which is 3.3. Pour again, and it's fine. This is an O2 this is an O4O2 resistor. Maybe due to the amount of the solder in here and the big plan, maybe this thing doesn't get to be soldered correctly because of using a solid pour. Now you can go here, basically edit this footprint, go to the override. In the override, instead of the zone settings, I'm gonna make it an exception by having thermal reliefs. Press B again, and now this particular part has thermal reliefs instead of the copper pour. These are very important stuff that you need. But basically, you can just remove this here, click pour, and connect it with a track. Let's put the track to be like half a millimeter. And that's it. Maybe you can do that if it's not really required to be very close. And what else there to explain? And okay, maybe this is all what's needed. Now let's go and make another one. Let's start from here, and I'm gonna choose it for ground, and this is the ground, and I'm gonna choose for both layers. I'm gonna name it GND. Okay, basically go outside the borders to make sure everything is selected, and then press B. And now both top layer and bottom layer, basically this is a top layer, this is the bottom layer, basically all of those are filled with this zone, the ground. But as you noticed, our 3.3 net 3.3 copper pour is now gone, despite it's there. Let's go check it out. The other copper pour has a zone priority level of 1, but this one has a priority level of 0, makes 1 bigger than 0. If I want this to be a priority, which is as it should, maybe I can assign 2. Press B again, and now this gets filled first, then it's get filled the other ones. This is important when you manage your copper pours. Now this is called a draw area. Let's put something like this. Area name, area 51, for example. Let's call it like that. And I'm gonna make something of a rule. I want the rule to be keep out zone fills. I don't want this to be filled with anything. I don't care about pads or vias or tracks. I just don't want it to be filled with any copper pour. I'm gonna define it like this. Press B again, and now this area is assigned as an exception. Okay, this is important if you want your inductor, for example, to have the copper ground, which is for the layer 1, not really poured under it, which is recommended, but you still want other layers to be okay. You can do it from here. You can basically also see, but because this one is an exception only to the copper layer, but the front copper. If you want it for everything, you can basically completely eliminate everything is under this. Something to be naughty with. Now all of these are drawing tools. We're gonna go about them like the following. First, let's go to the front silk screen and let's start the drawing. These are lines. You can basically draw them, but once you are finished, click right click and cancel. See, something like this. Basically all sets of tools that you can have. This is called the Bezier curve. I guess this one got inserted with KiCAD 9, and basically just drawing tools, nothing really special. Adding images, adding text, maybe design by me, for example. You can put it right here. Press edit. By the way, move by M, E by edit. The font, the everything, the alignment, the bold, for example, and there is a feature called knockout, which is something like this. See, now the word themselves are not solder mask, but everything else around them is something more of a aesthetic kind of thing. Drawing tables, drawing boxes, whatever. Draw orthogonal dimensions if you really want some dimensions like this, but it's not AutoCAD, so don't do that. The interactive deletion tool, I don't recommend using it because maybe it's not really practical. When I want something deleted, I highlight it and delete it. Grid origin, where is the 0, x equals 0 and x equals y point, not really important. And this is the measurement tool. I find myself using these like all the time. For example, I'm gonna use this to measure the pitch of this connector to find it is 5 millimeter. The capacitor is 5.5 millimeter, and basically all the measurement that you want. And now let's go to this area. This shows the grid or not. This thing is, if you have some override on the grid, it can show them. Here is, instead of x and y for your measurements and stuff, you can use the radian system. Really, I don't recommend that. Here you can choose inches, mils, or millimeters. For me, I choose millimeters. I recommend you do that. And now we have this to make the crosshair something like this. Maybe visually you prefer that. I don't. And this here makes moving stuff like this. For example, let's choose this. If we're gonna move them by pressing the space bar, I can only move them up or down, left or right, or 45 degrees. See, it snaps. Maybe something important if you want something neat. For me, I don't really do that. And here are the rat's nest. The rat's nest is basically, let's for example basically delete this. The rat's nest are these things. This is telling you that this is a 3.3 and the same footprint is here. These are the rat's nests, connecting them virtually. They're not really connected, but it's telling you that these should be connected together. If you don't like them, you can disable them from here, and the curved one as well. This makes the inactive layer dim. For example, like this. Now I am active on the top layer. I want everything to be dim. And here are the draw zone, either drawn or not drawn. No, I want them to be fully drawn so I can know which one is poured and which one is not. And here basically the same thing for the pads and the vias. Look at this for the vias. Draw them or not draw them. The pads, let's go to the pads. Draw or not draw. Basically, and the same for the tracks. Always keep this on. This is called the appearance. It makes this disappear. And this is the properties. When you select this, the position, the layer, whatever, the value, basically it's something if you like it, but I don't. So now we have the really gone into a comprehensive approach to this software, the PCB editor, and I'm confident that now you can know all of these tools and all of this stuff. But there are other stuff that are really important that we need to explain them later on. Now, after we have finished designing our board, of course we didn't, but let's assume that we do. Everything that you have to do is save, then go to the file and go to something called export. Now here are many other things that you need to export. We are interested in maybe if you want a 3D version of your board or something like that. You can export many stuff, and you can import also other stuff like non-KiCAD board. You can append a KiCAD board, but we're gonna go to fabrication output gearbars. Now the gearbars are the files that you are going to basically get and deliver to your manufacturer. Let's go to the project directory. This is my gearbars. I want to delete all of those. Okay, let's get back to here. This is the plot from here. I'm gonna plot the gearbars. Okay, these are the layers that I'm gonna plot, and the directory I also assigned it as gearbars folder within my project library project folder, and basically say plot. It plotted everything. Generate drill files, the same thing, generate. Now it is done. I always go to something like this, fabrication output. I go to something called component placement and generate position file. And if you want, basically you can put something like a footprint report or bill of materials, but bill of materials, I prefer doing them on the schematic. After you have exported your Gerber, you basically finished. Now there are other options here in the templates and I'm sorry, in the edit menu, the view menu, but basically they are all assigned either here or there or something like this. Not really something that is worth mentioning. Clean up tools if you want to clean this thing, and basically maybe you can self-study these if you really want them, but they are not gonna make or break your design. One last thing I wanted to tell you is if I want to make a teardrop, I have this track. I go to the pad, E to edit, and let's go here, connections, and I'm gonna make it add teardrop. Okay, now it added a teardrop. I just wanted to remind you that you can do this. Change footprints. If you want something like this, for example, or maybe like this, edit. From the edit menu here, you can check everything, and one of those things that you can check is change footprint. Basically, you can select the selected footprint, or any footprint with this designator, or any footprint with this value, or anything else basically with this footprint already assigned. If you want, you can change the footprint to something else and then press change and it will change that. And where are the others? Swap layers. I don't want to swap any layers, but if I want, for example, this capacitor, which is a surface mount cap, if I really want it to be not on the top layer but on the bottom layer, I can simply press F. Now it is flipped. Let's go to the 3D view, and it is already flipped in there. Okay, the edit. I can, if I really see that this footprint is wrong, I can go to edit library footprint, and it will open the footprint editor, which we will get to know in the future episodes. And I can basically save it from here. I can assign a 3D model. It's already have a 3D model, but I can select it from here and assign it, scale it, and rotate it to shape. And basically, if I need to override the clearance, override the copper zones connection, like we have studied before, we can really do that. So I'm gonna conclude this tutorial right here, and the next couple of tutorials will be, I hope that they will be a little bit shorter, and after that we will start to actually design and route more advanced boards as a continuation of this series. So please stay tuned for that, and for the time being, please like, share, and subscribe. That the tutorial courses on my channel on YouTube really helps when you subscribe and when you press the like button and share it. Please also check thundertronics.net and my Thundertronics store. I have my products shown in here. You can check them out. And basically like, share, and subscribe. It really helps me spreading these tutorials, and I'll see you in the next tutorial.